Hi everyone, thank you for joining us for today's webinar. My name is Neil Foley and I'm the Applications Engineer at RIZE. And today I'm going to be discussing best practices for producing jigs and fixtures with RIZE. I'll start with a quick overview of using jigs and fixtures and then discuss best practices and benefits when producing them with RIZE. I'm sure many of you are already plenty familiar with using them, so I'll keep the overview short. So jigs and fixtures are tools that are most often used in manufacturing. They link with one or more workpieces and help to secure and manipulate them during manufacturing processes. There are several benefits to using these devices rather than manipulating work by hand. The deterministic positioning they can provide ensures that the resulting parts from each use will be very accurate and interchangeable. The automation of positioning also allows tooling to be applied much faster, making the manufacturing process more efficient. Now, I'll speak briefly about the distinction between jigs and fixtures. There are several different ways that jigs and fixtures are defined depending on how they're being used and who you ask. So I'll just cover a few of the more common approaches. So a fixture is a component that has been fastened into place on a rigid surface, and it may be used to hold workpieces in place securely. Typically, any component alignment or tooling involved is then done by hand. That is also used to hold workpieces securely, but may not be fastened in place. Jigs are generally used to either guide tooling with respect to the workpiece or guide a workpiece with respect to the tooling element. Also, while fixtures are often designed to hold a variety of workpieces for a variety of processes, jigs are usually designed for use in one specific process on a single workpiece or a set of workpieces. Now, the image here shows a jig that's designed to guide a drill bit to the proper place on a part, and a fixture that gets fastened to a work table and clamps down on a workpiece. There are some other definitions in use elsewhere, and in some cases, a device may have attributes of both a jig and a fixture, but these definitions will cover the basics well enough for us. Here are some of the most common uses of jigs and fixtures. Clamps and work holding fixtures can secure workpieces in place for all sorts of processes. Brackets are a type of fixture that doesn't necessarily hold work in place, but may still be used to securely couple two or more components. Some examples of jigs include guides and templates for cutting, drilling, and aligning components during assembly. There's a huge variety of other creative ways of using these or similar devices depending on your application needs. Next, I'll discuss producing these parts and how to get the best results. So producing jigs or fixtures with RIZE has a few benefits compared to other methods. When compared to many other 3D printing methods, RIZE parts have a high material strength, and strength is quite important for holding workpieces steady during tooling and during repetitive presses. The fast rate of production and small amount of post-processing required also allows you to produce and revise your jig and fixture designs faster than other printing methods and much faster than traditional machining and manufacturing methods. A third benefit specific to RIZE is that the marking ink capability can be quite useful for annotating important information on the surface of the jig or fixture. This could include instructions or a datum marking for alignment. It could also include dimension information, such as the insert diameters shown in the image. If a jig is complex to use, marking ink could also be used to attach instructions for its use directly to the device. Next, I'm going to discuss some best practices and important things to consider when you're designing jigs and fixtures for production with RIZE. To maximize accuracy and repeatability, it's best to use some form of kinematic supports to ensure that every workpiece is identically located during the process. Remember that when using kinematic supports, the key is to use the minimum number necessary to achieve a deterministic position. For example, to support a basic cube as shown, this would mean using 3 supports on one surface, 2 on a second, and 1 on a third, with forces acting on the other surfaces to hold it in place. This approach prevents any variation in placement from one part to the next. However, in many cases, this degree of precision isn't quite necessary, and a simpler support method is sufficient. Now, considering the strength and durability requirements of many jig and fixture applications, it's best to also strengthen the part with ribs and fillets wherever possible, particularly at the thinner joints. Now, as I've discussed, the differences between jigs and fixtures can be ambiguous in some cases, but there are a few things to consider when making design decisions. So designing a jig usually involves specializing the design for a specific part and a specific process. This can offer a major boost in precision and efficiency, and the rapid rate of production that RIZE offers could allow you to produce custom jigs for many processes. But if you need to hold a variety of workpieces for a variety of processes, it may be more efficient to design more general purpose clamps or work holding fixtures. You could also consider whether it would be easier to move a jig with respect to the tooling, or move the tooling with respect to a fixture. It may be useful to experiment with a few different approaches to determine which will work best. Now, another useful method of supporting parts is to create a snug fit depression. This doesn't offer the same deterministic precision as kinematic supports, but it provides a sufficiently secure hold while allowing for very rapid assembly and removal to speed up and simplify processes even more. There are a few different methods for accomplishing this depending on the CAD program you used. I'm going to show one method that can be used in SolidWorks. So I'll open up that now. So this is a part that is going to be used to fix a multi-tool onto a tooling element. So we start with the main base of the part, and then what I'm going to do is hollow out a small section from the middle, and that will make a snug fit depression for the part to fit into. So the first thing I would do for this particular method is to go to Insert, Part, and then that's going to allow me to open a part that I already have here. So this is a multi-tool. Once you open the part, then you'll have the opportunity to mate it to different parts of the part that is already imported. So I'll show quickly. When it first comes in, you will see this list of options. So you want to make sure that this check mark is checked. And then when you confirm, then it will bring you to this menu, which allows you to create mates. And these mates will determine where the part will be located. So in this case, I have 3 mates determining how the part will be located. One of them shows that this point right here should pass through the Z-axis. This mate shows that the part should be 2 millimeters embedded into the surface of the base. And then this mate shows that we want this edge of the part to be parallel with this surface over here. Now the next step, once you have the part that you want hollowed out imported, is that you want to offset the surface. And the reason that you do that is that if you use the part as it is to hollow out the other base part, then it's going to be a very tight fit and you won't be able to fit the part into the depression because there won't be enough tolerance. So the next step is to create a surface. So I have here a surface offset from different faces on this multi-tool part, and I typically use an offset of 0.2 millimeters. 0.2 millimeters will create a pretty good fit. It's snug, but I've never run into any trouble with having too little space to fit the part into it. So once you've created your slicing surface, then you're going to use a split. And what the split does is it takes the slicing surfaces that you've created and the solid that you want to slice through, and it splits that solid into pieces based on those surfaces. So now at this point, we have several solid bodies and we only want to be working with one. So the next step is to do a body delete keep. And in this case, I chose to do a keep body and just clicked on this one split, this one base piece that I want. And that eliminated all of the extra. And then the last part is just to clean the model up a bit, remove any necessary material, and use some fillets to strengthen corners or make it cleaner when you're printing it. So let's see. All right, so here is a use case for the fixture that I just showed. So this is a multi-tool that includes a bottle opener at one end. In order to strengthen the bottle opener, we decided to replace the hook surface with a stronger metal plate inserted into a hand press. In order to hold the multi-tool securely in place with respect to the, I designed the fixture that you just saw to support the multi-tool and be fastened to the base of the hand press. The combination of the hand press and fixture could be called a jig, because in that case the tooling would be guided by the combination of those two pieces. So the fixture only took about 1 hour to print. so that within a single day, we were able to print and test a few iterations of the fixture for best fit and ease of use. And then there's also, you can see a QR code markup on the fixture, and that will allow a user to open diagrams and instructions on its use with a QR code scanner. So for example, they would be able to open a web page that showed the pictures that are shown here with some diagrams of how to assemble the multi-tool to the fixture and how to use the hand press to insert the metal plate. Here is another use case from our customer New Hudson Facades. They have been using RIZE to produce parts for a variety of applications, including work holding and clamping fixtures. The clamps shown here are used to hold custom aluminum extrusions manufactured for their glazing systems. Many of their projects required 100 or 200 unique fixtures, making this process very costly. So before printing them with RIZE, they had produced the fixtures either using traditional machining, which had a high material cost because they were using metal materials to produce them, or they were using plastic milling in other cases, which was cheaper and faster, but it had a high labor cost because it was more difficult to do successfully. So by switching to using RIZE to produce these fixtures, New Hudson Facades has been able to save 75% of the cost for each part compared to what they were spending on each part previously. So because of the safe and particulate-free process of RIZE, they were also able to keep the printer right by their desks in the office rather than off in the machine shop, which helped further speed up production of their many custom designs. So just to quickly review, jigs and fixtures are useful for improving accuracy, repeatability, and efficiency in manufacturing processes. RIZE technology offers strong parts, fast production with very little post-processing, and marking ink technology for integrated annotations. It's best to consider how to maximize strength and precision during the process of designing new jigs and fixtures, and there's a vast range of applications with which these devices can help. So that's all I have for today. Thank you for attending this webinar.